就是很介意你的头上。
Okay. Assalamualaikum. Good morning, everyone. Hello. Assalamualaikum. Good morning, everyone.
Good morning, Doctor.
Waalaikumsalam. Good morning, Doctor.
Salam, Doctor.
Assalamualaikum. Good morning, everyone. Okay. As promised, today and Wednesday is the revision week. Okay, so I already delegates the hard copy at my office. So everybody have one?
Yes, Prof.
Okay, so we start with this one, but this one is 2013-14. The scope is different that time. So this one is about PD controller. So this one KIV first, okay? Because it's out of scope. Later nanti we discuss, okay? Because this Wednesday there is no PD controller. And then question number 2 is the design a lag compensator. So this one also KIV, okay? Because lead compensator is not in the scope of the test 2, okay? So until gain adjustment. Okay, we do it later, okay? Take note, So we move to 2014 and 15, okay? Okay, these questions. Wenjin, can you read for me?
A given system can be conveniently improved with the existing design tools available in literatures, given a randomly selected open loop system as following. The open loop load plot for the system when k equal to 1 is given in figure Q1b. Using the gain adjustment technique in frequency domain, GS can be improved to yield better response. As a control engineer, using the information given, you are required to solve the following problems. Determine the value of k from the plot so that a phase margin of 60 degrees is obtained. Find the gain margin at this instant. Provide the transfer function of the system with the k obtained. Calculate the steady state error when k is as obtained in part B. Compare the kb obtained by the calculation with the one obtained from the plot. After certain duration, the original system is needed to operate at gain margin of 30 decibel. Do the necessary gain adjustment to find the corresponding phase margin at this instant.
Okay, thank you, Shashini. Right, so the open loop transfer function is here, third order system, 3 poles, system type 1. So system type 1 meaning KV. Yeah? Okay, so ESS 1 over KV. And the plot is given like this. Okay, right. So the first question, value of K from the book plot so that the phase margin 60 degrees is obtained. Find the gain margin at this instant. Okay. So in order to find phase margin 60 degrees, so minus 180 berapa? How much? Minus
120.
120. So you go to two graph now. Okay, two graph. Okay, magnitude and basic phase. So go to this one. One segment, 1, 2, 3, 4, 5. Berapa tu? 45 divided by 5. Minat betul? Guys?
Yes,
Minat, okay. So 99. 99 plus 9, 108. 108 plus 9. 108 plus 9 berapa? 117. 117. 117 plus 117 plus 9. So 1, 2, 3. Jadi dia tengah-tengah lah. Okay. Tengah-tengah. In the middle. Sebab, can you see? Can you see, guys?
yeah, yes, bro.
Okay, Mukri, what is the omega PM there?
Uh, 2.8 rep per second.
2.8 2.5 okay. 2.5 radian per second. Okay, so we go up 2.5. Okay, what is the decibel value there? Nur Hazika Shazwina. Berapa tu?
Negatif
20, 60, 40, 20. 20 bagi 5, 4 kan? Satu segmen 4. 44, 48 lah. Negative 48 decibel. Okay, negative 48 decibel. So, this graph need to be shift up. Okay, shift up sebanyak 48 decibels. Okay, so 2.5 over here. Okay, need to be shift up 48 decibels in order to achieve the phase margin 60 degrees. Okay, so lihat sini omega PM Mukri said 2.5. Okay, phase margin 60 degrees. Okay, gain curve need to be shift up 48 decibel. Okay, in order to achieve phase margin 60 degrees. So what is the value of gain there? Faris Haikal? Faris? Tak?
Ada, Prof.
Tak menyaut.
251.19. 251.19.
251.19.
1.19.
Boleh lah. Okay. So this is the amount of gain. This one is without decibel. Yang ini is in decibel. Okay. So what is the apa nama ni? Gain margin at that instant. Sharif, what is the gain margin at that instant? Sharif mana? Ada.
Oh, okey, ada. Sorry.
Kau ni mana?
Switch off mic.
Ayalah. Gain margin at that instant. Apa?
Idea tu.
Nak cari gain margin at that instant, we have to padam dulu lah. Padam dulu. Okay, we have to find the original GM initialnya berapa? Dekat minus 180 ni, when the phase curve cross at minus 180, so we have a omega GM. So omega dm over here is how many dB? Sharif.
Nampak. Negative 65.
Okay.
Ya lah.
65 decibel. Okay. So yang tadi tu 2.5 tu kat sini tu adalah omega PM dia. 2.5 radian per second kan. So which give you sini tadi berapa 48 kan. 48 decibel kan tadi. Shift up. Guys.
Yes, Prof. Negative 48.
Okay, so kena shift up 48 decibel. Dan origin punya gain margin, okay, gain margin full lah is 65 decibel. Okay, so the difference, okay, so the difference, the new gain margin at that instant is 65 minus 48. 65 minus 48 decibel. Berapa? Mana?
Seventeen.
17 apa? 17 years old.
Decibel.
17 decibel. Right. Okay. Sudah. Okay. Provide the transfer function of the system with the K obtained. Easy, very easy. Very easy. K over, what is the question? Over tadi? S
plus 8,
uh,
S plus 10.
10 ke 12?
12. Sorry.
Oh ya betul. 12. 12 eh? So, masuk dah tadi K tadi berapa? K tadi berapa? What is the value of K just now?
251.19.
251.19. Ni ya. Okay. Okay. Very easy. Okay. So the marker ada 2 marks kan. Straightforward. Calculate the steady state error when K is obtained in part B. Steady state error. Chung Hoi Ki. TV. Chung tak datang. Chung tak datang. Datang tak datang? Kosong ni markah ni apa? Kehadiran kosong. Datang tak?
Datang.
Panggil nama sebut respon mah. 251.2. Sihat. 251.
2.62.
Okay. So potong. Berapa? KV berapa?
2.62. So,
1 over 2.62. Berapa? 1 over 2.62.
0.382.
Okay. Thank you. Okay. Compare the KV obtained by calculation with the one obtained from the board plot. Macam mana tu? So as I told you before, KV, we have two methods to calculate KV. One is using a formula. Okay, this one. And the other one is by observations. Okay, by observations from here. What is the value of KV?
2.5.
2.5. Bagus. Siapa budak ni? Syahir 2.5 It's 2.5 radian per second, which is equal to KV, which is equal to omega omega apa tadi? Omega PM. Okay, 2.5 radian per second. Calculations by observations. Okay, the gain curve with slope minus 20 dB per decade, cut at 0 dB, 2.5 radian per second. So KV, this one is by observations, which is more or less near to the calculation value 0.382. After certain duration, the original system is needed to operate gain margin of 30 decibel. Do the necessary gain adjustment to find the corresponding phase margin at this instant. Okay. What? How to do it? Any idea? See Michin?
Yes, Doctor.
Idea? The last one?
So, we need to find the original gain margin first, and then minus with the 30, get the new K, like that.
The gain margin definition is when the phase curve cut at minus 180 kan?
Yeah.
Okay, so done. Okay, so this one is omega GM lah, 10 eh. So 10. You can see what okay, nampak. Kalau tak nampak begitu. Berapa ni sini Chin?
Negative 65. 65.
73 lah. Ni 73 decibel. Okay, let's say.
Okay.
73 decibels. Okay, so we need to adjust the key such that it will give you the gain margin 30 degrees. Okay, so therefore kita tolak aja lah. Okay, 73 minus 30 decibels. How much? 43 decibels. Okay, 43 decibels. So that is the amount yang kita kena amount of key to find the corresponding phase margin at this instant. Do the necessary. So 20 log 73 minus 30. Okay. Berapa ni? Kita nak dapatkan dia punya gain key tu. Sekejap. 20 log K 73 minus 30. K sama dengan 43 divided by 20. Berapa?
141.25.
141.25. Okay. So what is the phase margin at this time, at this instant? Con yang when?
Yes, doctor.
What is the phase margin at this instant? Jadi kalau dia 30 degrees, gain margin 30 degrees. 20, 40. Okay, 20 divided by 5, 4 lah. Kan? 28, 24, 28. So dia kat bawah ni. 20. Macam mana nak cari phase margin instant? Benson?
WPN at 30 dB.
Sorry?
Find the phase omega PN at 30
How to
dB
find the omega PM?
from the graph.
From the
Draw
graph.
the line.
How? How?
Gain plot, I will draw a vertical line down to the x-axis. 30 dB.
30 dB.
Yeah, we draw a vertical line down.
So I padam dulu lah, confusing. Okay, again, Benson.
Yeah, line for negative 30 dB.
Negative 30 24, 28, 32. So tengah-tengah lah sini.
Ya.
Betul? Kena kat situ berapa?
0.3.
Okay. So this one is omega PM. Okay. Then it goes down 0.3, yeah?
Yeah.
So what is the phase over there? Roughly minus 45. 45 kan? So 1, 2, 3, 4, 5. What is the value of phase here?
Negative 99.
99. Okay lah. 99 decibel eh? So that's why phase margin at this instant is minus 99 minus 180. Berapa? Syahir?
81.
Boleh lah. Tengok use. Okay.
Doctor,
Yup.
why not cut at 43 dB?
Why not cut at 43 dB?
Yeah,
Because
the 73 dB move out to 30 ma. So at 0 dB should be 43 dB.
because 43 is the adjustment, the gain adjustment. So the targeted is 30 decibel.
Yeah.
The targeted is 30. The targeted gain margin is 30 decibel. 43 decibel is the amount of gain to shift up the gain curve. Did I answer your question?
Okay, let me think first.
Okay. Next question. This one, black compositor, KIV. Okay. KIV guys. Nanti later kita bincang. Ni. Okay, this one. Everybody turn to this page. Ika, baca.
A1 using a graphical method to find the gain margin and phase
Bukan dua ke?
margin. A2 from the bird plot of a system. How do we know that the system is either stable or unstable?
Okay, stop.
Good.
Tak bising bunyi. Nick, can you continue reading? Start from the beginning.
Yes, bro. Question 1A, using a graphical method, define the gain margin and phase margin. Number 2, from the bird plot of a system, how do we know that the system is either stable or unstable? B, a unity feedback system has an open loop transfer function, GS, as given. By using a frequency response technique, the bird plot of the open loop system with K0.01 is as shown in figures Q1B and Q1B3. Obtain the gain margin and phase margin of the system and determine the stability of the system. Find the value of gain needed for the system to give a phase margin of 48 degrees. Determine the new gain K and the new gain margin at this instance. By comparing the gain margin in question 1 and question 2, explain the effect to the stability of the system using the K obtained in question 2. Determine the steady state error of the system for a ramp unit.
Very input. Okay. Okay, graphical method. Okay. But phase minus 180 will give you the gain margin. Okay. This one, gain at 0 dB. So gain at 0 dB will give you the phase margin. Okay. But this one is unstable because the gain margin is negative. Okay. So graphical kan. So the other one is macam ni. Okay. Okay. This one is the phase. This one is the gain. Okay. So this one is omega PM. Omega G. Phase margin positive. Gain margin positive. Okay. Okay. So this one is stable. This is the way I understand, to explain graphical method. Maybe you have your own style, but I don't know whether you can. I think that this one is the best lah, where you combine the 0 dB and minus 180 in one line. Okay. Kalau dia unstable, marginal macam mana? If how to explain graphical stability in marginal? Ismail. This one is unstable. This one is stable. Marginal. Ismail. Oh shit, datang. Absent.
Yes, doctor. Omega phase margin.
Where are you? Far away.
And it's at the threshold.
Oh, in the class. So this is a unstable graphical, stable graphical, and for marginal graphical, how you explain? No idea. Tika? Tika? Tak tahu. Tak tahu lah.
Prof, bukan. Okay. Tak apalah, Prof.
Di online ni budak-budak lemak ni. Tebal lemak ni. Gain pula. Face. Okay. So it's face. And this one is a gain. And at this point, okay. Okay. This one is considered as marginal. Okay guys? Boleh? Hello, boleh?
Boleh, Prof. Boleh.
Boleh, boleh.
Tak pula aku nak cakap orang ni. Okay. So now we come to the real one. Okay. Banyak ni. Ini the conclude system with K 0.01 is shown in the QB2 and QB3. Okay. So dah bagi dah. Macam ni lah dia bagi. So obtain the gain margin and phase margin of the system and determine the stability. Liana, gain margin and phase margin please. Liana Camelia.
Yes, Prof.
Gain margin and phase margin. Right.
Ini berapa tadi?
Siapa yang cakap tu? Tak dapat? Izul? Oh, tengah buat.
Ada betul.
Izul?
Ya saya doktor.
Omega PM berapa? Omega GM berapa?
Omega PM 0.004.
Okay.
Omega GM 7.5. 7.8. 7.5 macam tu lah. Betul.
Dia ada macam tu 7.6 macam tu.
Ya, okay kau. Phase margin, gain margin?
Phase margin negatif 90.
7.5. Ni kan?
Ya.
Negatif 90. Tak sampai. Besar sangat. Gain margin lebih kurang
78.
Ni minus 80. So lebih kurang 72 lah.
72.
Seperti itu dah sebab. Okay. Omega phase margin sini jadi dia punya ni berapa? Phase margin ni 0.1 kan? Sini kan? So lebih kurang sini phase margin 90 darjah. Okay, positif. Stable Okay, Liana, kita dah kira untuk awak.
Dua. Phase margin dengan gain margin.
Dah. Speak off. Find the value of gain needed for the system to give a phase margin of 48 degrees. Determine the new gain K and the gain margin at this instant. Okay. Macam nanti dia berulang balik. Okay, so kita padam balik lah. This one. Okay, so the new phase margin 48 degrees, previously 90 degrees. So reduce almost half. What is the gain K? Okay, 48 degrees. Jadi kalau 48 degrees minus 180. Yuki Wong. 48 minus 180.
Negative 132.
Negative 132. Oh, tukar nama ke? 132. Negative 132, 135. Lebih kurang sini lah Okay. So ini akan memberikan phase margin 48 degrees and the omega PM is 2. So we go up 2. What is the value of decibel over there? Semi?
Negative 85.
Huh?
Negative 58. Negative 58.
What is the reading of decibel of 2 radian per second over there? Gain curve. This one. $40, $44, $48, $52, $56. Okay? 56 decibel. Okay? So the amount of shifted is 56 decibel. Okay. Sammy, how much? Do you really okay?
$630.96.
630.
630.96.
Okay. 630. Okay. So what is the question? So the new gain K will be K new 630 multiplied by 0.01. From where? Yeah. Can. Natra, berapa ni? Natra, 630 multiplied by 0.01.
6.3.
Huh?
6.3.
6.3. And what is the new gain margin?
Betul, why we need to multiply 0.01?
Yeah. 2 K 0.01.
Alright, Doctor.
Gain margin at this instant, Simichin?
Yes, Doctor.
What is the gain margin at this instance? Meaning that we have to find the phase curve cross at minus 180 kan? Berapa dia punya ni? Omega PM?
At 7.5 ya?
Huh?
7.5 radian per second.
7.5 sorry. 7.5 radian per second, then move up. I delete this one too, confusing. Seven point five, sini ya. So 7.5, berapa decibel tu?
Negative 72.
Negative 72 Okay. So beza dia berapa? $72 minus 56. How much?
Oh, 16.
16 decibel. So this is the gain margin at this instance. Okay, dia punya beza dia yang lama dengan yang baru. By comparing the gain margin in 1 and 2, explain the effect of the stability system. 2 is much better. Okay. Compare to 1. Because the range of stability is bigger or higher. Okay. Using the K obtained in 2, determine the steady state error of the system with the random input. Okay, direct aja. So K dia tadi berapa?
Doctor, I want to ask about the question 3. They say 2 is much better compared to 1. So the value for gain margin in 2 is...
Ni berapa tadi? Gain margin mula-mula berapa? The first one berapa?
72.
72 decibel. Yang ni tadi?
16.
16 decibel. Okay, sorry. Yang ini is 1. Sorry ya. Balik. Okay. 1 is much better compared to 2 because the range of stability is bigger and higher. If you see that this one 16 decibels, the old one 72 decibel. So 16 decibel is more towards 0. If the gain margin 0, so the system become marginal. 16 decibel still stable, but much better 72 decibel because it's far away, more stable. Okay. Did I answer your question?
Yes, Doctor.
Okay, K. How to calculate the K? Maina. Senyap aja. Maina.
Ya, Doktor.
Syarif pada situ. Apa dibuat? S berapa tadi? K kan? 100 panjang. Betul tak? Betul tak?
Betul.
S plus 5. S plus 10. S plus S berapa? 500.
Yes.
K yang we get just now, how much? Aina? K yang kita dapat tadi.
6.3.
Oh, kita dah padam lah. 6.3 multiply 100 multiply 100. Betul? Ya, dia. Berapa? Ini. Saya tak ada kalkulator. Alright.
.52.
52. So the error will be
0.39. 0.4.
Okay. Ini lain.
Excuse me, doctor.
Yeah.
For the last question, it says that steady state error for the system having a ramp input. Does that differ from like the other error questions, or is the same thing? Does the ramp input here change anything?
The RAM input is because the system is system type 1, they just put their RAM input. Actually, for position, we use step. For RAM, also can, okay, because if we look at the control 1 theory, okay, so this is RAM input, and this is input RAM. And the output will be slightly like this. Okay, so this one we call it as steady state error. The one that I always show is like this. This is the input. This is the output. This one also considered as steady state error, but input is step. Okay, square wave. But this one is triangular wave, so it is RAM. Okay, the concept is the same. Steady state error. The difference between input and output. Did I answer your question?
Yes, thank you.
Later, I also want to ask if the question ask for the KV in the graph. So is it KV is equal to omega phase margin?
Not necessary. Not necessary. It depends on the ruler that you use. So you have to, you know, macam ni kan. This is type 1. Okay. So KV can we can use calculation, the formula I showed just now, or use your ruler that I gave to you. Do you have my ruler, free ruler? Shahid?
I already have my ruler.
You already have your ruler, right? Because you're a very good student. Okay, so in this case, when it cut at 0 dB, berapa ni? Berapa?
0.003.
So this one is the KB lah, kan? 0.035 lah, okay, when it cut to 0 dB. So this one is minus 20 dB per decade. Okay, line tu. observations. Observation and calculation. So observation, of course, is near to the calculations. Okay, guys, we break 10 minutes break boleh tak?
Boleh doktor.
Boleh doktor.
Jangan pergi mana-mana. Okay, sekejap lagi kita sambung.
Saya lanjut.
Okay, guys, we continue. What there? Okay, question 2, KIV. Not in the scope because is a lag compensator. Okay, but you can try this part first. Okay. Then this one is 16, 17. I am not in the list. I'm not in the team. Okay. And you can see that they repeat the question. Okay. They repeat the question again. Okay. But this time around, they change from 48 to 45 degrees. Maybe I suspect the first test majority failed. So they become a lenient and they repeat again the questions, but change the 48 degrees to 45 degrees. And then this one, KIV, was a lag compensator. Okay, but you can do it, but not in the scope of the Wednesday test. And 2017-18, I was not in the team as well. Repeat again the question. Okay, so you can see that they repeat again the question. So this time K equal to 1. Last time 0.01. Okay. Maintain 45 degrees. Let's change the question. Maybe they don't have any idea how to do it. This one, lag compensator, KIV as well. Okay, later on. Okay, we go to this one. This one is question number during MCO. Okay, during MCO, we only have one test. So chapter 1, chapter 2, and chapter 3 together, because we only have one test online. Diana, tolong baca. Diana.
Yes. Unity feedback system represented by figure Q3.1 has an overlook transfer function as GES. The frequency response of GS and KGS is given in figure Q3.2a and Q3.2b. KGS is the plot of the system when gain K is applied. Given KGS is the upper plot and GS is the bottom plot as labeled. Determine the stability of GS by examining the system's gain margin and phase margin. Hence, identify the phase margin frequency and gain margin frequency. Using the magnitude plot of KGS, identify the new gain applied. Hence, from the plot, determine the range of K, the system to be stable.
So we see the plot. Okay. The solid line lah, solid line. Chua leh ho? Miss Chua?
Yes, doctor.
Gain margin and phase margin.
Hold on, yeah, doctor.
This one is 0.002. Thank you. Okay. Phase margin 90 degrees. Sure. Right.
Yeah.
And gain margin. Gain margin itu berapa frekuensi dia?
70.
Itu decibel. Correct.
Yeah.
Okay. Yeah. You buat tak?
I got 70 something. Okay.
Okay. Right. Okay. Phase margin frequency dah tadi dah. Okay, ni dia. Okay. 0.002 and 19. And then using the magnitude plot of KGS, identify the new gain applied. Hence, from the plot, determine the range of K of the system to be stable. Macam mana nak buat? So, kita delete dulu lah delete. Lokman, macam mana nak buat? Lokman. Oh, Lokman. Datang. Datang One moment.
Ya, Doktor.
So the graph has been shifted up. Yang ni. So how many decibel has been shifted up? Huh?
Around 33 decibels.
64 decibel Apa? What? Hmm? 64 divided by
50.
Huh?
50.1.
50. 50 lah. Right. Dia punya range of apa dia cakap tu? Okay. To be stable. What is the range? Between 0 to 50 lah. More or less. So dia mesti dalam range ni. More than that, dia jadi marginal stable. Okay. Right. Then so soalan MCO is very easy lah. PKP. But face to face is quite difficult. Right. This one. I invite Patrick. Can you read for me? Patrick, where are you?
For the transfer function, ts equal to from this past state immediately expression and face equal to the value of medical and face value and new equals when we sketch the case of envelope for the system, Q is equal to 100 over x plus using a simple example for box sketch, larger begin margin, and the face margin and their corresponding crossover for C.
Bising Patrick punya background. Okay. Mathematical expression for this one. This is theory question. Okay. Tika, macam mana Tika? Mathematical expression. In decibel and in degree. Any idea, Atika? Datang. Okay. G omega plus 6. Okay. So that is the mathematical expression, the general one. We substitute with S is equal to J omega, and from there we derive the decibel. Okay. Berapa? 3. 1, 2, 3. Gain 1 over S and 1 over S plus 6. Tak ada? Tak datang. Okay. Tak datang. Daniel, tolong ketika dia tak datang. G omega Daniel Zulkifli 20 log 12 is the constant. This one kan? And this one is the pulse at the origin minus 20 log omega. Okay? This one kan? Kalau kita ambil magnitude, so it's become square root square omega kan? Minus 20 log omega square plus 6 square. Okay, yang ni. Sebab d omega plus 6 magnitude is omega square plus 36. Okay, so that is the mathematical expression. Majority student don't know how to do this. Okay, majority lah. Phase in degree. Okay. G omega. So for 12 is constant. So constant punya phase adalah 0 degree. Okay, and then for phase for 1 over S is minus 90 degree. And then for the pulse at 6 is inverse tangent omega divided by 9. Okay. So we already answered the questions here. Okay. So what is the value of the magnitude and phase when the angular frequency 20 radian per second? So for omega 20 radian per second, G omega berapa? Mana? 20 log 12 minus 20 log 20 lah, 20 log 12, 20 log 20 radian per second. Siapa mana? Berapa ni? Log 20 square plus 36. Berapa?
Negative 30.83.
Bos. Kemudian phase. Kosong darjah tolak 90 darjah tolak tangent omega 20 bagi dengan 6 berapa? Leong? Ko Ho Leong? Ko Ho Leong? Tak tahu. Jason Long?
Yes sir, yes sir. Give me a second. 6 pair.
Minus. Minus ni.
I get 16.7.
What? 16.7? I think
Yeah.
it's wrong. I think it's wrong.
Negative 163.3.
Negative 163.3. Okay. Sketch. Okay. So what is the difference between sketch and draw? Wing Jin. Second question. What is the difference between sketch and draw?
Sketch, just hand sketch. Simply sketch.
Sketch, freehand draw.
Yeah.
Draw. Draw. Sketch, draw.
Draw properly in the graph.
Using scale graph. Okay. Sketches.
Shoes.
Sure, oh, bagus, pandai. Shopping bagus. 100 plus S divided by 10. Sketch lah. You know how to sketch? Sketch. Sketch, the transfer function is ds. But before you sketch, make sure you normalize, can you? Normalize. Normalize first. So, see Michin, how you normalize, can?
10. Make the lower one become 1 plus
like this,
something. Like this. Yeah.
Okay. Now, what is the break frequency? Ika, break frequency berapa? Tak. Adam? Adam?
Yes, sir.
Break frequency berapa? Tak tahu. Matthew? Puluh lah. 10 radian per second kan. So, apa yang kita buat adalah S divided by 10 plus 1. Okay. So we have two factor. One is constant, one is pulse at the real axis kan. So 20 log 10. 20 decibel kan. Okay. Jadi kalau kita sketch, decibel. Then this one start from 0. Enter. So you campur kan berapa? Can you add these two factor? this one and this one, add together. So it will be total. Okay, when you add together. How about the phase? So phase for constant 10 is 0 degree, and then for S plus 1 is this one is the number 1, and number 2 is okay. So the total will be, so 0 plus the phase, so it become similar total. Okay. Using a suitable example of both sketch, illustrate the gain margin GM, phase margin PM, dan their corresponding frequency. I think this one dah explain dalam yang tadi tu. I explain here. Yeah. Ni. Okay. You explain ni. So much easy to understand. Okay. Boleh? Guys, boleh?
Boleh bro, insyaAllah.
Okay. The end. So Wednesday you want a class? Relax lah. Focus pada test. Wednesday, you want a class or not? No need, huh? Hello guys. Wednesday, you need a class or not? If those who don't understand, come and see me. So Wednesday, no class. I give you free time because it's only 1 hour. Then we continue revision and presentations of assignment next week, plus the lead compensator. Any question? Nur Hazika, ada soalan?
Ada Prof.
Ya dah. Kamu sudah prepare, Ba?
Sikit-sikit.
Sikit-sikit, Ba. Ni?
Yeah, Prof.
Wednesday no class, so free time to study or sleeping.
But you are available for question, right?
Sure.
Okay, thank you, Doctor.
Anytime, anywhere, no problem. But I'm not feeling well today. Okay. You see that doctor take blood from my hand to identify what is the problem. But I'm recovering, inshallah. Okay. Hope the best. Hope for the best. Prepare for the worst. Okay, guys. Any question? No, no, eh? So I will share the YouTube later. Thank you very much. Assalamualaikum.
Thank you, Doctor.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Thank you, boss.